So what I did for the next two sections is I actually put them together into one lesson. And the reason being is because they are very similar. They use the same theorems and the converse of those theorems. So you're going to be talking about parallelograms today. So the first thing is, what is a parallelogram? A parallelogram is a quadrilateral, so something with four sides, where both pairs of opposite sides are parallel from each other. So your first theorem says, if a quadrilateral is a parallelogram, then its opposite sides are congruent. So if I have a parallelogram, every time my opposite sides will be congruent. Then the next piece is more vocab, where it's talking about consecutive angles. Those are the angles of a polygon that share a side. So for example, in this parallelogram, B and C are consecutive angles. The reason I was pointing that out is because in your next theorem, it refers to a consecutive angle. So the next theorem says, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So if I have a parallelogram, these two angles, these two angles, these two angles, or those two angles, all will add to 180. Lastly, on this front side of your note-taking guide, the theorem says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So if I have a parallelogram, then B and D are congruent to each other, and A and C. So a lot of that was just introductory stuff. We have one more, and then we'll actually start doing some more solving. So theorem 6.6 says, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So if I have a parallelogram, then these diagonals, which means it's a line connecting the vertices, those will bisect each other. So remember, bisect means it will cut it into half. So from here to here and here to there will be equal to each other, and the same thing with the other. So now we're actually going to do some math and apply what all of those theorems were saying. So your first diagram, you have a parallelogram, and it's asking you to find what x is. So if you go back to your theorems, theorem 6.4 would be the one that we want to apply, because the consecutive angles will always be supplementary. So I can add these two angles to equal 180. So 3x plus 7 plus 110 would equal 180, and then I just do some algebra to solve. So I combined my like terms and got 117, subtracted 117 from 180 and got 63, and then divided by 3 and got 21. So now let's look at number 2. Number 2 has another parallelogram, and it's giving me expressions for the outside edges. So that would apply to theorem 6.3, where your opposite sides are always congruent. So you can set those two expressions equal to each other because they're congruent, and then do some solving. So I would subtract 5x from 10x and get 5x equals 10, and then divide by 5 to equal 2. I would like for you to pause the video and try questions 3 and 4. Okay, after trying question 3, here's how I would do it. So notice that they give you expressions for all four sides. You know that opposite sides are congruent. So again, theorem 6.3 would apply, where I would just set opposite sides congruent. So you can use either pair. So I used the top and the bottom, set them equal to each other, and then I solved it. So that means I subtracted 2x from 3x and got 1x. Then I added 2 to 6 and got x equaling 8. So then for the next problem, they give you an expression for all four angles, and you have two different ways you could do it. You could do consecutive angles that are supplementary, or you could do opposite angles are congruent. I set it up that opposite angles are congruent. So I set x plus 35 equaling 2x minus 5, and then I did some solving. So I subtracted 1x from over here, and then added 5 to 35 and got x equaling 40. Now let's try number 5 together. So on number 5, similar to the last, where you have an expression for opposite angles, so noticing that those opposite angles would be congruent by theorem 6.5, so I would set them equal to each other, subtract x, and then divide by 2. So my answer would be x equaling 30. Pause the video and see if you can do question 6. So on question 6, you're going to see that they're going to give you diagonals and they're going to give you an expression for half of the diagonal. So theorem 6.6 would apply because diagonals will bisect each other for a parallelogram. So I would just set the two expressions equal to each other and solve. So I subtracted 3x from 4x and then added 1 to 4, so I got x equaling 5. So that takes care of everything from section 6.2.